Hi everyone. So here I am with my paper presentation. So the topic or research paper which I selected for this course, which is Introduce Our Physical System Security, the paper which I selected is From Very Weak to Very Strong, Analyzing Password Strength Meters. And so this is my paper presentation, and my name is Ahsan Razali. This is my GTID. So in this particular paper, what I would be presenting, so this is the outline of my presentation. So first I would cover what I'm talking about, like what the problem is. Then I would be specifically giving an overview of the problem, then a brief introduction, and then just going down to the technical details of the paper, which basically concerns about various password checkers or meters available on various public and big websites and their specifications. Then I would describe some testing and evaluation done to support the idea and further the results, and followed by some future perspective. And then I would give some takeaway, some fruit for thought for further analysis, or anyone else if want to take a research dive or further deep dive in this particular topic, and then the references for this presentation. So now coming back to, first I would describe what the problem is. So the problem this particular paper tries to solve is, or try to present is, it present basically a comparison of various password checking meters who provide the opportunity to enter the password, and they assign then a label like weak, strong, fair to the password entered. So this particular study looks 11 of such big surface password meters or password checkers like Google, Service, Drupal, Skype, Apple, Microsoft, and some are more, and then compares their password security, their checker security, compares the inconsistencies between them, and compares their algorithm, that how they how their algorithm perform in various conditions, are the algorithm consistent or not. So the studies about this aspect, that how to secure or how to make any password checker, or what are the lacks, or what are the inconsistencies available in today's password checkers. So this is a beautiful GIF image presenting the idea of this study. Moving next, uh, this is a brief overview of this research study. So the overview is basically this particular study analyzes password meters and checkers deployed in popular websites. So these checkers, the selected websites or the selected checkers for the websites include mainly Google, Microsoft, Apple, Yahoo, Skype, and many more. And then to report prominent characteristics of password checkers. What are their characteristics? How they differ from each other? How various meters differ in the categorization of password? So categorization of the password are different for different checkers. So how they differ, and what criterions they differ from each other. And then author specifically talks about some weaknesses and gives examples of those weaknesses. Those are available on those deployed checkers or meters. And at last, they present their findings with some suggestions that how to make these password checkers more consistent, more secure, and more usable for the end users. So the selected checkers for this particular study, analyzes these 11 checkers. They are Dropbox, Drupal, FedEx, Microsoft, Twitter, Yahoo, eBay, Google, Skype, Apple, PayPal. So here is the service name or the type that the authors just analyzed for these particular password checker the client side of the checker. For these checker they analyze the server side of the checkers, and for these two they analyze both client side and server side of the checkers. So they checked what their methodology is, how they compare, how they perform on various dictionaries, and what are the results, what are the inconsistencies among the checkers and between the types as well. So as I talked before, these are the key players selected, whose password checking surfaces are selected. So moving next, so a brief introduction about the password meters as described in the research study. So basically they are deployed on major websites like Google, Apple, Twitter, Dropbox, and pre presence of their meters let users make strong choices. So the good thing is now user community is aware of that how they need to set their password, what kind of strength is required, because password checkers usually enforce that by enforcing the users to provide a, a feasible strength of the password. Strengths and weaknesses of checkers are rarely studied. So this particular study is kind of we can say initial studies of there are only some number of studies available out there in the research arena which explore the password checkers and their strengths and weaknesses and inconsistencies. So both client side and server side services are studied. So how they did that is they basically extracted the client side and server side code and fed that code to the uh, algorithm by having variety and hundred and thousands of dictionary passwords, and then analyze the behavior of particular password checker. So then they estimated the weakness and strength of each password checker, and then at the end they provide a preliminary analysis and their recommendation that how the password checkers can be made more consistent, more strong, and more usable, keeping view the end user community of these. So these are any general kind of sources we can say. So main contributions are basically they characterize the checker, that what are the characteristics of the checkers specifically and how they differ from one another. Then they evaluate the checkers, their weaknesses, their strengths by setting up an experimental setup. So they have their own algorithm, so which attacks on these password checkers, and then their loopholes or their weaknesses and strengths uh, come up, and they so this is all done through their experimental setup. Then the weaknesses are explored. So their main contribution is the development of test tools for the experimental setup and to unveil the weaknesses and the strengths of password checkers, and at last they provide recommendations for how a good password checker can be constructed, or what are the main requirements for a usable password checker which is consistent, really consistent. So in the study, the authors laid to stress on consistency because they found the inconsistency between various checkers, so which is really problematic. So now coming towards the password checkers or password meters, selected 11 password checkers and meters overview. So usually these password checkers are implemented on various websites at two of the main places, which are either a registration page where the user comes and registers itself, and user has to provide a password, and at that point password strength is usually checked by today's checker. Another possible place where password checkers are available are password update page. So once if a user wants to update the password, then he or she needs to enter the password to update its password. So the key characteristics selected for they studied for the selected checkers are available below. They are character set and length requirement. So some password checkers requires the users. I mean all of the checkers, all of the 11 checkers. They enforce the user force the user to provide a minimum or maximum length of password characters. Some provide special characters to include, some provide space character to include or not. So they are inconsistent between the passwords. Some provide in the option of special characters, some of the special characters to be included in the password, some are not. So there are some labels. So there are a variety of labels associated when it comes to assigning the strength of the password, like weak, fair, strong, or poor, medium, good, or weak, fair, strong, too good. So these are inconsistent between between various password checkers. So next is importance of user information in check. So some password checkers take into account users' information, and they suggest some password based on the contextual information like account number or email. So like for example, if the user's name is Asan, so then password may not then the checker may not allow you to add that username into your password. So again, these are inconsistencies between various checkers. Some allow, some don't allow. So here it's like that. So various types of there are password checkers, like some checks the password or the strength of the password on client side, some check on the server side, some check on both hybrid or on both sides, like client side and server side. So for this we can refer back to the table one, like for the selected passwords here. And these are these are the password select these are the services who who have the functionality of checking the password strength at client side. They have the functionality of checking the password on server side, and they have both. So they are again different for different um, password checkers. Again, so there are diversity of the password checkers. So every password checker has its own logic. Like when I say every, it means the selected 11. From the selected 11 password checkers or meters, every password checker has its own logic. So, but it's strange that except Dropbox from the 11, only Dropbox just explains the methodology or algorithm of the password checking mechanism they employ, and rest any of the 11 password checker do not give you any information about how their password checking algorithm works basically. So then password score estimation is another key characteristics. So to assign a password, like to assign a strength label to the password, that like this particular password is strong or this is weak, a score is calculated. So that score we call is score, password score, that is assigned to the password based on the label. And this score estimation again is the algorithm or the way of the estimating the score is again very inconsistent and differ among the password checkers. So in the nutshell, in this particular table, I've summarized like this was available in the study. So I've just reproduced this table from the study, and it summarizes that which service uses which type of password checking mechanism and what label they assign, what are the minimum and maximum length of password can be used, or character set, special character set they allow or not. One plus lower, one plus upper means that they allow you to include lower characters and um, capital letters and digits. And again, user info means that they uh, incorporate the user information. They allow you the user information, the contextual user information in your password. So this is again a brief summarization of the characteristics which we discussed before this in a nice tabular form. So here you see, so the interesting thing is that that look how the strength scale varies from one password service to another, like Drupal strength scale accounts like very weak to so good, great. And Drupal includes weak, fair, good, strong. FedEx has another strategy to label its password strength, and so on and so forth. So again, within these top service providers, these 11 top service providers, there is so much variety of strength scale. So again, this inconsistency. So, the study specifically talks about these inconsistencies between the password checkers. So that when the user comes or the user experiences variety of these services, and usually sometimes users get confused, like from one strength scale, from one service, the strength scale for one password is very weak, and for the same password for another service, that particular password may be labeled as strong or good or medium and so on. So the paper lays heavy focus on these inconsistencies available basically. So for testing the password, for testing their algorithms, for testing these methodologies of these 11 checkers, the authors have implied or created test tool. So this particular section, which names automating tests for evaluation, describes that how they automated the tests for the evaluation of the selected 13 websites. So here it's 13, but actually the companies or services 11. But Microsoft's three password checkers, two old and one new one, are employed. So a total of 13 comes about. So they are tested. So this particular automating tests for evaluation for the password checkers are described here in this section. So for client-side checker, what the author proposed methodology, or what they've done is they extracted the JavaScript functions and the strength score of dictionary passwords are computed, so and stored in a DB. So they extracted the client-side code, and uh, they provided the passwords from the dictionaries to those functions and computed their strength score. So for every password, a strength score was computed, and that strength score was then um uh, just dumped in the database. For server side, the checkers URL, so JavaScript code in this case is obtained using PHP script. So passwords from the dictionaries, which I will be discussing in the next slides about the dictionaries. So in the batch mode, the passwords are sent for testing, and so to make the connections alive, or to send as many passwords as possible, connections remain alive, and they remain alive because the authors said that they want to send as maximum request as possible before the connection just dies out. So what that amount is basically that was a maximum 64 passwords per send were sent. So no blocking mechanism was employed here. So for hybrid checkers, those provide checking mechanism on both client side and the server side. So so both tests were performed. Tests were performed on client side, and tests were performed on at the server side. So for this, for testing the password methodologies of the 11 services, 11 password checking meters, variety of dictionaries are applied. So these dictionaries, what the author said, they have some of the dictionaries are open source dictionaries, so some are leaked dictionaries. So some of the dictionaries the author just made, just developed their own. So this is a nice table, just summarizing the in the dictionaries employed for the testing and number of words, so maximum length, average length, and standard deviation. So like for top 500 is an 499 words were there in this particular dictionary having maximum length of 8 and average length of 6. So these are dictionaries. So lead transform dictionaries, like dictionaries having the passwords, having the characters, having their shape similarities, like E can have the lead transformation of 3. And so those passwords having the lead transformations, this, so those are available in this lead dictionary. So this lead dictionary has 6,48,116 passwords. So so there's a beautiful trend that they start from minimum and they go on increasing that. So 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 they have in total they have employed 11 dictionaries for this testing and evaluation of the algorithms of the 11 sources. So now we would discuss each and every 11 sources, that after the execution of the tests on their password checking mechanism, what results, what evaluation is drawn out, what results or what significant outcome is drawn from each of the password checkers. So we would start from Dropbox. So Dropbox have basically a client-side open source algorithm. So it implements client-side implementation algorithm. It's open source. This is the only open source algorithm available. So for testing, password is decomposed and the total score, total strength score is first calculated. So passwords are realistically decomposed in equal chunks and then they are compared. So the finding was that behaviors were inconsistent, like for one password from coming from one dictionary, who is labeled as strong, but once a very small modification is made, and that similar password, that password is labeled as very weak. So these inconsistent behaviors were shown by Dropbox algorithm. Next is Google. So Google employs a server-side checker. It also has an inconsistent behavior. It runs a blacklist run. Google checks when a new password arrives to the password checking algorithm. Google checks from the dictionary, blacklist dictionary from the Google has maintained itself. So this blacklist run or checking is done by the Google. So dictionary password are good to use. So one observation made is that password from the dictionaries were oh, people were able to use them. So again, this one of one of the problem with Google password checker is that it suffers from hysteresis phenomena. So it has a very what we can say vague kind of uh, so Google suffers from hysteresis phenomena. So eBay provides a server-side checker, so they have a comparison of character sets. So user information usually or contextual user information is not considered. Again, they also have an inconsistent password label assignment behavior. Some passwords are given a strong label, with a very small modification, they go to very weak. So this is an inconsistent password behavior, as we have checked for the previous checkers. Apple provides a hybrid, like client-side and server-side password checker. So client-side algorithm is increasing only. They also blacklist the they run the blacklist runs, like when the password arrives at the checker, they check from the blacklist either it's available in the dictionary or not. So, but Apple's password checker is a rich password checker, contains comprehensive data from variety of dictionaries to compare. So, but the thing is that repetitive patterns are catchy. Like if you place repetitive patterns in password, so that password without those repetitive patterns can be termed in Apple's checker as as very weak, but providing those repetitive patterns, they may be strong, or it may label it strong or something. So FedEx surprisingly has a string and very strong or very strict password checkers. So they first check the password with the dictionaries they are available with them, and if they obey the requirements, then that password can be considered as the true password. So, but the thing is, their algorithm can also be defeated by adding a single character to the password. So if the password is weak, you add a single character, the password becomes very strong. So here are some results presented, keeping in view the analysis of the tools or the overall analysis of the checkers performed in the study, that there are really inconsistencies or heterogeneity available between the passwords. Target dictionary for FedEx. So the authors developed a targeted dictionary because the FedEx has a stringent or very strong password meter. So to counter that, or to check the FedEx password checker in more detail, a more targeted dictionaries was developed. Comparisons were made, and so various implications of design choices are analyzed, and the stringency bypass, that how to bypass the password checker, is also analyzed here. So again, Google checker hypothesis is discussed, and various password policies are discussed in the study. So some key issues or key takeaways this particular study gives are the online versus offline attacks. What are some of the implications of online, or what we can say offline attacks, and how they are they can be countered. So like client side checkers, as tested, can perform either very strong or very loosely, and like server side checkers may behave like similarly. Like for example, they have tested with Skype and Google, and they found that their server side checkers behave very loosely. And finally, when it comes to hybrid checkers, they behave mostly like client-side checkers with an additional server-side blacklist mechanism. So, they provide server-side blacklist run along with client-side's mechanism. So, these are some of the uh, implications. So some conclusions drawn from this particular study are that password, everyone knows passwords are essential mean to authenticate one's identity. So they provide a feedback at the user, but the feedback should be consistent across. We see that the feedback was not consistent, it remained inconsistent throughout. Commonly used passwords are really inconsistent. They fail to provide coherent feedback on user choices really, and they provide strength measurement that are bluntly misleading. So strength labels are misleading. They vary from one password to another. So it is very difficult in this particular situation and with this particular knowledge and implications to develop a strong password mechanism or checker is really difficult. So top password checker services, and they are simple. They have no complexity, but so because they have no complexity in their algorithm backend, they somehow ignore some of the design choices, and then they provide some misleading suggestions. So key takeaways of this study are that common password checkers applied to the top web services like we discussed for these 11 are less reliable. They need serious effort from academia and industry and serious academic research to further solidify their implementation is required, and new such password checking modalities needs to be explored to further solidify this particular area and make the password checking meters more usable, more consistent, more predictable, more user oriented, and more strong in terms of the security. And finally, we have these some of the references. So these references correspond to why the password meters, the implementation of password meters are necessary. So these studies present the analysis or the usefulness of password meters. So like, yeah, this is my presentation on the topic. So I'm really thank you for all for your time.